Hi everyone. This project was called, somewhat humorously, GObject Detector. It has nothing to do with GObject. It has to do with the game Go, which, as you can see, you play against Gordon Freeman while aliens watch. Seriously, it's a 4,000-year-old board game, and you place black and white stones on the intersection. So I had a bit of a personal itch. After games, you often want to review your game and step through all the moves and try and analyze mistakes and the like. But a game goes on about 250 moves, so stopping to record after every move is a bit tedious, and remembering it isn't an impossible task, but is difficult to do consistently. So basically I've been writing some code to take an image of a Go board and transcribe it to SGF, which means Smart Game Format, which people use for Go. So basically how it, oh wow, it's really dark. Does anybody get the lights down here? Yeah, it's a little better. So first you start from an image, and this is just a very low resolution cell phone image. I think it's processed at like 200 by 200. And then there's a computer vision algorithm called the Canny Edge Detector, which basically identifies maximum gradient areas in the image, where the image is changing the most. And it just has a binary sort of output. So first we create this image, and then there is another algorithm called the hue transform, which is used to find the most distinct lines in images. So basically we apply the hue transform to this image to find these 4 red lines. Sorry, the images are really hard to see, I don't know why it's so dark. So once we have the 4 red lines, we can find the corners, and then we compute a perspective transformation to get a bird's eye view. Then it just identifies the grid, which I've thought some about actually trying to process the grid lines, but there's a standard width-height ratio for boards, so once you order the corners correctly, the grid points are easy to identify. The main problem with there's lots of glare. You're playing on a shiny board with white stones, so lots of images will involve glare and lots of wood grain noise. So basically after that I speed up on the image a little to get it down to, I think there are like 6 colors in this image, and anything that's black is full black, anything that's white is full white. It's all pretty, I guess it's all pretty textbook computer vision stuff. There was one sort of interesting thing I've been working with to basically make a light map of the board to try and equalize the lighting. And then once you have an image like this, right, you can just sample in a circle around each grid point and see if you got all black or white to detect the stone. So what I'm going to do with this is I'm going to write an Android app that you could set it up to watch yourself play, and it'll listen for the sound of, it's a pretty distinctive click when a stone hits the board, and it'll take a picture and transcribe that move. And then Peter said he might write me an iPhone app, but I don't even know what an iPhone is.
It's those things you put under amps.
Yeah, that's true. Sorry, I don't know how to use preview. Okay. Whoa.
Yeah, you hit space.
So this library.
Hit
space again. You put it into like autoplay.
There you go.
Okay. So again, nothing to do with GObject. Something else I might do with it is set up something where you could play online games using your physical board and you just play on the board and it recognizes it and sends it to the server. Probably needs a new name. Go image manipulation package and Go toolkit have also been excluded. And then I have another program which I've been working on and they'll probably release soon to, it's basically like iTunes except for your database of Go game records. And I'll probably integrate it with that. Seems nice to have. Any questions?
What libraries were you using for that image?
I'm using OpenCV for a lot of it.
Yeah.
And I use the Python imaging library for some of the image processing. I'm probably going to rewrite it in C. I mean, rewriting in C would be a very quick task. I just wrote it in Python initially to test things out.
Okay.
So you wrote it in Python or in C?
It's in Python right now, but
So the image processing libraries are all in Python or in C?
well, OpenCV is a C library, and I'm using the
Python binding.
bindings. But it would be very trivial to convert. I just haven't. I just wanted to get it done in Python first to make sure it worked.
And what is the schedule for releasing it?
I'll probably release at least the library code soon. I haven't done really anything for the Android app yet, but I think once I get the library code a little more robust, it still sometimes isn't too great when the stones aren't precisely placed. So I want to tweak that a little, and then I'll release that, work on the Android app. But
Library code, releasing a library code is a great service.
yeah, I just need to, there's a lot of thresholding and the like, and a lot of numbers just need to be tweaked to get it more resilient. Anything else? Andrew?
I was wondering why you decided to detect the click of the piece on the board instead of just continually taking pictures and waiting for a change in the board state.
Oh, just battery life. I mean,
Okay.
A game could go on for like 2 or 3 hours, and I don't even know if my phone could record video for that long. Yeah?
Well, speaking of battery life, the computation of just doing the image processing, how is that going to...
It's pretty low key. I mean, the first thing that's done, this is very easy. And again, this is very easy. And once we get it, it's so hard to see. But once it's transformed onto a 200 by 200 image. So it's just very quick to operate on. Like, it's instantaneous on my computer, so I assume it won't be a significant problem. The image can even go down to, again, half the size, and it still gets the good results most of the time. So might have to tweak it some though, and maybe get rid of some, try and cut out maybe some of the processing I do is a bit overdone. Yeah.
So when you talk about correction factors, it sounded like you were hard-coding them, or are you looking to make them automated? Because depending upon how I take the photo, you could have very different correction factors.
Right, well there's a lot that are hard-coded. But one example is here, like to generate the processed image, it takes, this sounds kind of ridiculous, but it scales the image down to like a 4x4 copy of itself, and then scaled it back up with anti-aliasing to make like a map of where the bright and dark areas are, and then divides the original image by that. And it does lots of things to equalize out the colors, and it smooths out all of the wood grain. So the thresholds are hard-coded, but it does a lot of work to homogenize the images.
So we'll take one from Zach, and then the next speaker is Colin. You can go on board. Yeah, Zach, you can ask the question.
This is going to be a dumb question, but won't people's hands and things be in the way when they're trying to take photos?
Yeah, so that will require a little tweaking. I mean, you won't want to take the photo
When it clicks,
right
your hand is on the board.
right, but you can wait a while, and it should be pretty easy to detect if there's a hand obscuring the photo, and then you can just say try again
Oh, okay.
in a second or two. I think the Android app, getting it working in real time so you can just have it watch you play, will require a lot of tweaking. Initially, it'll be useful just to transcribe at the end of a game, because even just seeing the position at the end of the game is probably enough for most good players to remember the game. Okay, is that all?
Colin is next.
Okay.